Okay. Okay. Okay, the cubes. One, 8, 27, 64, 125, 216, 343, 512, 729, 1000. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. 1729, 512, 343, 216, 125, 64, 27, 8, 1. 1029, 512, 343, 216, 125, 64, 27, 8, 1. And the second set. 1331, 1728, 2197, 2744, 3375, 4096, 4913, 5832, 6859, 8000. And back. 8000, 6859, 5832, 4913, 4096, 3375, 2744, 2197, 1728, 1331. And forward by hooks. 11 cubed is 1331, 12 cubed is 1728, 13 cubed is 2197, 14 cubed is 2744, 15 cubed is 3375, 16 cubed is 4096, 17 cubed is 4913, 18 cubed is 5832, 19 cubed is 6859, 20 cubed is 8000. And reverse by hooks. 20 cubed is 8000, 19 cubed is 6859, 18 cubed is 5832, 17 cubed is 4913, 16 cubed is 4096, 15 cubed is 3375, 14 cubed is 2744, 13 cubed is 2197, 12 cubed is 1728, 11 cubed is 1331. And forward by digits. 1331, 1728, 2197, 2744, 3375, 4096, 4913, 5832, 6859. And back by digits. 6859, 5832, 4913, 4096, 3375, 2744, 2197, 1728, 1331. And the last set. 9261, 10,648, 12,167, 13,824, 15,625, 17,576, 19,683. Believe it's 21,952, 24,389, 27,000, but we must check. So we turn to table 22. Three times. 17,576, 19,683, 21,952, 24,389, 27,000. And again. 17,576, 19,683, 21,952, 24,389, 27,000. And again, 17,576, 19,683, 21,952, 24,389, 27,000. And back. 27,000, 24,389, 21,952, 19,683, 17,576. Okay. And by hooks. Hello. Yes, I do. 21 cubed, 9,261. 22 cubed, 10,648. 23 cubed, 12,167. 24 cubed, 13,824. 25 cubed, 15,625. 26 cubed, 17,576. 27 cubed, 19,683. 28 cubed, 21,952. 29 cubed, 24,389. 30 cubed, 27,000. And back by hooks. Alright, let's just see here. Okay. Alright, last set, backwards by hooks. 30 cubed, 27,000. 29 cubed, 24,389. 28 cubed, 21,952. 27 cubed, 19,683. 26 cubed, 17,576. 25 cubed, 15,625. 24 cubed, 13,824. 23 cubed, 12,197. 22 cubed, 10,648. 21 cubed, 9,261. Okay, so it's nearly there now. You just need to leave it for a few more days. And now, formulae rather. Okay. X cubed minus y cubed is x minus y times x squared at xy at y squared. A cubed minus b cubed is a minus b times a squared at ab at b squared. C cubed minus d cubed is c minus d all times c squared plus cd plus d squared. And we check. 10 cubed minus 2 cubed should be 10 minus 2 all times 10 squared at 10 times 2 at 2 squared. 10 cubed minus 2 cubed is 1,000 minus 8, which is 992, and that should be 8 all times 100 plus 20 plus 4, which is 8 times 124, which is indeed 992. X cubed add y cubed is x add y all times x squared take xy add y squared. X cubed add y cubed is x add y all times x squared, take xy, add y squared. A cubed at b cubed is a at, again, a cubed at b cubed is a at b all times. A squared, take ab, add b squared. C cubed at d cubed is c at d all times. C squared, take cd, add d squared. And we check. 10 cubed at 2 cubed is, or should be rather, 10 add 2 all times. 10 squared, take 10 times 2, add 2 squared. So on the left we have 1008, and on the right we have 12 all times. 100 take 20 plus 4. 100 take 20 plus 4 is 84. 84 times 12 is, yes, indeed, 1008. Okay, difference of fourth powers. X to the 4 minus y to the 4 is x minus y times x plus y times x squared at y squared. X to the 4 minus x to the 4 minus y to the 4 is x minus y times x plus y times x squared at y squared. A to the 4 minus b to the 4 is a minus b times a plus b times a squared at b squared. C to the 4 minus d to the 4 is c minus d times c plus d times c squared at d squared. And we check. 3 to the 4 minus 2 to the 4 should be 3 minus 2 times 2, 3 minus 2 times 3 plus 2 times 3 squared at 2 squared. On the left we have 81 minus 16, which is 65. And on the right we have 1 times 5 times 13, which is correct. Alright, so we're going to see difference of fifth powers. X to the 5 minus y to the 5 is x minus y all times. X to the 4 plus x cubed y plus x cubed. X to the 5 minus y to the 5 is x minus y all times. X to the 4 plus x cubed y plus x squared y squared plus xy cubed plus y to the 4. X to the 5 minus y to the 5 is x minus y all times. X to the 4 plus x cubed y plus x squared y squared plus xy cubed plus y to the 4. A to the 5 minus b to the 5 is a minus b all times. A to the 4 plus a... Try again. A to the 5 minus b to the 5 is a minus b all times. A to the 4 plus a cubed b plus a squared b squared plus ab cubed plus b to the 4. C to the 5 minus d to the 5 is c minus d all times. C to the 4 plus c cubed d plus c squared d squared plus cd cubed plus d to the 4. And we check. 3 to the 5 minus 2 to the 5 should be 3 minus 2 all times. 3 to the 4 plus 3 cubed times 2 plus 3 squared times 2 squared plus 3 times 2 cubed plus 2 to the 4. And on the left we have 3 to the 5 minus 2 to the 5, which is 243 minus 32, which is 200 211. Now, that's a prime number, so it's going to be kind of strange, but on the right-hand side, we have 3 minus 1, or rather 3 minus 2, which is 1, and therefore we expect what's in the brackets to be wait a minute. Yeah, we expect what's in the brackets to evaluate to 211. So first we have 3 to the 4, which is 81, plus 3 cubed times 2, which is 54, and thus 135, plus 3 squared times 2 squared, which is 36, and thus 171, plus 3 times 2 cubed, which is 24, and thus 195, plus 2 to the 4, which is 16, and thus 211. So it works. Right, now we turn to problems. Right, this setup here is kind of you know what? You know, just not bother with it. Right, that's fine. Doesn't matter. All right, set 10. Find the time 2026 minutes after 8:26 p.m. on a Monday. 2026 minutes. There are 1,440 minutes in a day, and so it will be on Wednesday. So we have 560 plus 26, so 586 minutes remaining. 586 minutes. Which is 9 hours and 46 minutes. 9 hours and 46 minutes. So add 10 hours and take away 14 minutes. So if we add 10 hours to 8:26 p.m., we get 6:26 a.m. 6:26 a.m. Now we subtract 14. We subtract 14. So we get 6:12 a.m. It will be 6:12 a.m. on a Wednesday. So you ask us what time is 2026 minutes after 8:26 p.m. on a Monday. We've forgotten. All right, maybe if I do this. No, that doesn't Darn it. I wonder if there's something which can sort of like lock it in. Doesn't sort of apply to the other one. All right. Oh man. How am I gonna do this? All right, so it's temporarily stable. Anyway. Let's just repeat that. What time is 2026 minutes after 8:26 p.m. on a Monday? There are 1,440 minutes in a day. And thus, 2026 minutes is 1 day and 586 minutes. 586 minutes is 9 hours and 46 minutes. 9 hours and 46 minutes. We add on 1 day and 10 hours and then subtract 14 minutes. So we add 1 day and we get Tuesday, 8:26 p.m. We add 10 hours and we get Wednesday, 6:26 a.m. We take 14 minutes and we get Wednesday, 6:12 a.m. Wednesday, 6:12 a.m. So you ask us, what time is it 2026 minutes after 8:26 p.m. on a Monday? And we say Wednesday, 6:12 a.m. How many distinct prime factors does 2025 have? 2025 is 45 squared, which means that its prime factorization is 3 to the 4 times 5 squared. So it has 2 distinct prime factors if you're just counting the 3 and the 5. 6 prime factors if you're counting all those that make up its prime factorization. And that's what we can say about that. So how many distinct prime factors does 2025 have? We say 2 or 6 depending on how you count, but more likely 2. Which of, no, that should be right. Which of 1, 2, 2.01, 2.1, or 2.2 is closest to 10 over 9 plus 9 over 10? Common denominator would be 90. So it becomes 100 over 90 plus 90 over, rather, 100 over 90 plus 81 over 90, which becomes 181 over 90. Which, when we divide 181 by 9, we get, let's see here. Alright, so we could do that. Yes, we get 20 and 1/9. 20 and 1/9. Which is 20 point recurring 1. And then we divide that by 10 and we get 2.0 recurring 1. 2.0 recurring 1. So which of them is closest? The answer is 2.01. So you ask us which is closest to 10 over 9 plus 9 over 10, and you say to us 1 or 2 or 2.01 or 2.1 or 2.2, and we say 2.01. Lines y equals px plus 4 and py equals qx minus 7 meet at 3, 1. Find q. Y is equal to px plus 4. Y is equal to px plus 4. And therefore, they meet at 3, 1. Thus, just subbing in 3 and 1, we should readily find q as we get a pair of simultaneous equations. So we just recite y equals px plus 4 and py equals qx minus 7. So in the first one, we have 1 equals 3p plus 4. 1 equals 3p plus 4. And in the second, we have p equals 3q minus 7. So 1 is equal to 1 equals 3p plus 4. So 3p equals negative 3. So p is equal to negative 1. P is equal to negative 1. Now, in the second equation, you say py equals qx minus 7. So we can say on the left, negative 1 times 1, which is negative 1. Negative 1 equals 3x minus 7. Or rather, negative 1 equals 3q minus 7. So 6 is equal to 3q. So q is equal to 2. So you say to us that the lines y equals px plus 4 and py equals qx minus 7 meet at 3, 1, and you ask us what q is, and we say q equals 2. Beg your pardon? If 23x plus 977y equals 2023 and 977x plus 23y equals 2977, what is x squared minus y squared? Did I get that right? If 23x plus 977y equals 2023 and 977x plus 23y equals 2977, what is x squared minus y squared? Okay, so if we add the equations together crudely, we get 1000x at 1000y equals 5000. Right? So x at y is equal to 5. X at y is equal to 5. Now, they say find x squared take y squared. We know that x squared take y squared is x take y times x plus y. And we already know that x at y is equal to 5. So now we just need to, by a similar argument, find x minus y. Alright, okay. Alright, we'll do the first, take away the second, and just see what happens. 23x minus 977x. So minus 954x. (977y) minus 23y, so 954y. So negative 954x plus 954y. 2023 minus 2,977. Negative 954. So minus x plus y, minus x plus y. Minus x plus y is equal to 1. So y minus x is equal to 1. So x minus y is equal to minus 1. So we have x plus y, which is 5, and we have x minus y, which is minus 1. And thus we believe that x squared minus y squared is minus 5. So you say to us 23x at 977y is equal to 2023, and 977x at 23y is equal to 2977, and then you ask us what x squared minus y squared is, and we say minus 5. How many coins are in 20 pounds of 5p coins and 50 pounds of 2p coins? 20 pounds of 5p coins, well, there are 25p coins in a pound, and there's 20 pounds worth of them there, and therefore there's 400 coins in the first pile. There are 52p pieces to make up a pound, and there are 50 pounds worth in the second pile, and thus there are 2,500 coins in the second pile. Putting the 400 from the first and 2,500 from the second together, we get 2,900 coins altogether. So you ask us, how many coins are there in 20 pounds of 5p pieces and 50 pounds of 2p pieces, and we say 2,900. How many straight lines form an n square grid? We believe that the answer is n add 1 times n add 1, or rather, 2 lots of n add 1, 2 lots of n add 1. And we check as in the 1 by 1 case, we see it's 4, and that checks out. In the 2 by 2 case, we see that it's 6, and that checks out. And in the 3 by 3 case, we see that it's 8, and that checks out. So it's 2 lots of n add 1. So you ask us how many straight lines form an n by n square grid, and we say 2 times brackets n add 1. Evaluate 3 lots of 2018, all divided by 4 lots of 2018. This is obviously 3/4. So 3 lots of 2018 all over 4 lots of 2018 is obviously 3/4. Find the units digit of 2015 squared plus 2015 to the 0, plus 2015 to the 1, plus 2015 to the 5. To determine the units digit, we need to find the units digits of the addends. So for 2015 squared, it will end in a 5. For 2015 to the 0, it is 1. For 2015 to the 1, it will end in a 5. And for 2015 to the 5, end in a 5. And thus, the units that we will be adding together are 5, 1, and 5, and 1, and 5, and 5, which totals to 16. So the units digit will be 6. So you ask us for the units digit of 2015 to the 2, 20 plus 2015 to the 0, plus 2015 to the 1, plus 2015 to the 5, and we say it's 6. In the valid addition, P45 plus QRS equals 654. Find the sum P at Q at R at S, where P, Q, R, and S are single digits. Not sure how much of the last one got gobbled up, but there you go. Alright, now we must check for set 10. Oh, that's actually supposed to be -5. That's fine, that's fine. That's fine, that's fine, that's fine. Alright, just one that we have to correct, and that's number 5. Okay, we shall correct it now. If 23x plus 977y is equal to 2023, and 977x plus 23y is equal to 2977, then what is x squared to take y squared? Adding the two equations together, we get 1000x add 1000y is equal to 5000, and therefore x add y is equal to 5. X squared take y squared is equal to x add y times x take y. So we already know that x add y is equal to 5. Now we just need to find x take y. X take y. Okay, so subtracting second from the first, that is 23x minus 977x, which is minus 954x, and then 977y minus 23y, which is 954y, and then 2023 minus 2977, which is minus 954. So we have negative 954x plus 954y equals negative 954. We divide through by 954 and we get negative x plus y equals negative 1. So y minus x is equal to minus 1. So x minus y is equal to 1. And so they're vindicated. x squared take y squared must be 5. Alright, so we detected the error. That's fine. Okay. So now, set 11. If today is Thursday, what day is it in 100 days? In 98 days, it will be Thursday as well, that being the 14th multiple of 7. And so in 99 days, it will be Friday, and in 100 days, it will be Saturday. You ask us if today is Thursday, what day will it be in 100 days from now? And we say Saturday. Evaluate 6 over 12, take 5 over 12, plus 4 over 12, take 3 over 12, plus 2 over 12, take 1 over 12. One giant fraction with 12 on the denominator, and on the numerator, 6 take 5, add 4, take 3, take 2, add 1. Let's just hear that one again. 6 take 5, add 4, take 3, add 1. Corrected. 6 take 5 is 1. 1 add 4 is 5. 5 take 3 is 2. 2 add 2 is 4. And 4 take 1 is 3. So it's 3 over 12, and thus we get 1/4. Another way to look at it is to put it into 3 groups, each of them worth a 12th, each of them worth a 12th, another group which is 1/4. Alright, but to be clear, you asked us to do 6 over 12 take 5 over 12, add 4 over 12 take 3 over 12, add 2 over 12 take 1 over 12, and we say 1/4. How many minutes from 11:35 p.m. today to 1:15 a.m. tomorrow? 25 minutes to midnight. Another 60 minutes to get to 1 a.m., so 85 minutes. And another 15 minutes to get to 1:15 a.m., so 100 minutes. You ask us how many minutes from 11:35 p.m. today to 1:15 a.m. tomorrow, and we say 100 minutes. Which of the following is not a square? 1 to the 6, 2 to the 5, 3 to the 4, 4 to the 3, or 5 to the 2. One to the 6 is 1, which is a perfect square. 2 to the 5 is 32, which is not a square. It's not a square. So we already know that it's 2 to the 5. But for completeness sake, we will tell you that 3 to the 4 is the square of 9. 4 to the 3 is the square of 64. And 5 to the 2 is the square of 5, of course. So you ask us which of the following is not a square, and you say 1 to the 6, 5 to the 2, 4 to the 3, 3 to the 4, or let me just try that again. You say which of the following is not a square, and you say 1 to the 6, 2 to the 5, 3 to the 4, 4 to the 3, 5 to the 2, and we say 2 to the 5. Find the remainder when 2,600,000 Find the remainder when 2,613,524 is divided by 13. Visualizing the bus stop method and then seeing that seeing the 13 times table like right in front of us by grouping the digits as 26, 52, wait, we need to be correct. What is the remainder when 2,651,000? No. What is the remainder when 2,652,134 is divided by 13? Visualizing the bus stop method and then partitioning the dividend into pairs of 2 digits, we can clearly see the 13 times table. 26, 52, 13, and then a 4 at the end. So above them we write 20401, and then we can clearly see that the remainder will be what? 4. The remainder will be 4. Because, let me put it this way, that will convince you. If I multiply 20401 by 13, I get 265213. And then if I multiply that by 10, I get 2652130. That's on the 13 times table. Then if I add 4, I get the original number that we're supposed to be dividing by 13, which is 2652134. So the remainder must be 4. A download is 95% complete. What fraction of the download remains? We say 1/20th. A download is 95% complete. What fraction of the A download is 95% complete. What fraction of the download remains? We say 1/20th. Rectangle PQRS has these coordinates of P, Q, and R, and we are to find S. Right, we dropped it. We need to do it again. Rectangle PQRS has the following coordinates for P, Q, and R, and we have to find out the coordinates for S. P is 1,1, Q is 7,4, R is 5,8. All right. So what we need to do how can we efficiently do this? So I know that to get from P to Q, you have to add the vector, 6, 3. And to get from 7, 4 to 5, 8. -2. And then 4. Visualize, visualize. Visualize. Alright, so we have to pause here for duties, but this is something I've never visualized properly before, so I'll learn that.